Start recording. All right. So, okay, everybody, welcome again to Xeno Mining Educational Class on Blockchain Fundamentals series. This is your host, the Mac Composer. We're going to talk about immersion mining today. I just want to make sure everybody can see my screen. Is that true? Give me a thumbs up or... Yep. Great. Okay. So last week, before we dive into immersion, we talked about mining basics. And if that's something that you haven't checked out yet, I highly encourage you to just recap a little bit on what mining is and what to do, to get started in mining. Now, when we talked about mining last time, mining was very much talking about air-cooled mining setups. All right, I even went through the whole process of how to calculate how much electricity you need versus also how much heat dissipation you need to be worried about. We talked all about that. Now today we're going to get into another form of mining. It's called immersion mining, and immersion mining is something that Xeno is very interested in. We're actually building our own mining farm, and within that farm we're going to create an immersion mining sort of setup. So this is a very, very exciting topic for Xeno, and this is going to be something that's very, very relevant to us as investors. Okay, so the more we understand why we're doing it, the things that we're doing, the more we can feel confident about the future of where we're going with Xeno and all that kind of stuff, right? So I hope you all agree. And in this case, immersion is something that I haven't been able to personally get into myself because there is a lot of upfront cost to it, but I'm very familiar with what goes into it. I've done my own research on this, and I wish to share that with you today. So let's go in. All right, so first things first, what is immersion cooling? So immersion cooling is basically a method of cooling computer components by submerging them in something we call a dielectric fluid. So dielectric fluids are non-conductive fluids. So it means that electricity won't pass through them. They are almost kind of like an insulator in a sense. Now, if we are just to kind of define what insulation means, it just means it's the slow transfer of energy, right? So from, let's say, you got a cooler with an ice box, inside it, right? So the ice, when it's out on a hot day on the beach, right, it still stays as ice inside the cooler because there is a good amount of insulation, right? So here's the same kind of concept. Dielectric fluid is a very, very good insulator. And actually, if you didn't know, dielectric fluid is just an oil. Okay, so oil is actually pretty resistant to electricity in this case. So, and it's a coolant that can efficiently absorb heat. So this method has been adopted by some cryptocurrency miners to cool their mining rigs. This is happening, I would say, I don't want to, spew out misinformation, but I think probably around like maybe 20% of miners out around the world are maybe involved in some form of immersion mining. Okay. Maybe even less, I'm definitely, I think I overshoot that. But the idea of managing heat exhaustion from crypto mining machines or ASICs is very, very key to our operations. We spoke about that last time, okay, with the air cooling. Miners typically choose between air cooling or immersion cooling setups, but immersion cooling setups are much more efficient at moving heat away from the miners than their air-cooled systems, especially at scale. Now, the reason for this is because you actually have direct contact with hot components with immersion cooling. The difference with air, right, we have to actually move air, and air is not a very, very efficient way of tackling heat because there's a lot of molecules that are very, very kind of far apart in comparison to something that's much more dense like, immersion fluid. This is a big, big proponent as to why immersion works so well. Okay, so just understand that just on a more physics level, we're actually having direct contact with hot components, and that's why this works even better. So the dielectric fluid is a kind of fluid that is resistant to conductivity, right? And conductivity is just electrical, sort of electrons and these atoms that are much more likely to sort of move around. Okay, we have conductivity is kind of like this highway, okay, of sort of like electrons that are moving back and forth. It's one of the reasons why when you talk about something, let's say like a copper pan, okay, just to relates to something completely different, but maybe this analogy might help you understand. Copper pans, right, they're much more conductive of heat and electricity. What does that mean? It means that electrons are more likely to move around, to their destination, okay, faster. That's why it's easy to heat them up. It's also easy for them to cool down. If you're using something else, I don't know, try putting a glass, type of pan. Glass pan will take a little bit longer to heat up versus the copper pan, okay, because it's not as conductive. That being said, okay, so because the dielectric fluid is resistant to conductivity, right? I always like to remember dielectricity as electricity, like die. Like there's no electricity passing through it, okay? But it allows this safe harbor. It allows for these components to not be so easily shorted, etc. Okay? So the liquid allows this heat transfer much more efficiently with that direct contact like we spoke about, and it will replace the heat with immediate relief from recycled cold fluid that is pumped through the infrastructure. Okay? Any questions before I move on? All right. Make sure to also, if you have any questions as I go along, you can also put it in the voice chat. Just or stop me if you have a question. I am totally okay with that. All right, a little more of an overview. In traditional air-cooled mining rigs, heat dissipated through fans and heat sinks, which is resulting in a significant amount of noise and high energy consumption. So this is the problem with a lot of air-cooled systems, and you'll see like big mining farms that are doing air-cooled systems. They're in a much more remote place. They can't be around, city folk or anything of that sort. It's too noisy. If anyone here is into sound like I am, I mean these things churn up anywhere between 82 decibels to 90 decibels. That's ridiculous. That's literally like hearing damage. So immersion cooling, on the other hand, offers several advantages, such as a higher energy efficiency and reduced noise and increased lifespan of mining equipment. So efficiency for mining is one of the biggest things that we talked about in Mining Basics last week. Again, if you're interested in learning more about that, check that lesson before this one. But efficiency is a huge proponent in order to getting more return back on your investment, okay? So the immersion cooling process involves placing the mining rig components, such as graphic processing units or ASICs for that matter, in a specialized tank filled with a non-conductive fluid like mineral oil, okay? This is just one example, and I'll go over the difference between things like dedicated dielectric fluid versus something like mineral oil, okay? But the idea is the fluid absorbs the heat that's generated by the GPUs or the ASICs, and it transfers it to an exchanger, which removes the heat from the system, okay? It's just like a pipe system that happens in order for this to work. So by using immersion cooling, one of the benefits that we can get with that is overclocking. Is that amazing? So miners, we can increase our mining power without worrying about overheating or damaging the equipment, because we're so much more efficient at cooling the miner that we get to actually extract more from the mining itself. It's more eco-friendly, there's reduced energy consumption, and noise levels are, just almost non-existent when it comes to immersion. This is so much better in terms of efficiency in its grand scheme. So immersion cooling is more efficient because companies, even like Engineered Fluids, they claim that air cooling consumes about 40 to 50% of the total energy usage. 5% or less of the total power consumption is used by the device's onboard fans alone, right? So just that. I mean, and you know, as we talked about this last week again, okay, mining is not just about, using, the power just to get the miners up and running. You have to also get the utility of everything else that has to go around it to keep things cool and all that kind of stuff, right? So here's an example that even just on the miner itself, 5% of the entire miner's power is dedicated just to the fans, okay? That's a lot of power. So, and some of these miners, they're like 3,000 watts, right? So that's quite a bit of power. So miners who opt for an immersion cooling setup may be able to run their machines at a higher hash rate per minute, or per machine, I should say. Immersion cooling also does not require miners to clean the machines as regularly for dust and dirt and natural buildup, because the immersion fluid actually takes care of that. It's right inside. It's always inside this fluid. The fluid is always in motion. So whatever gets in there, dust or whatever, or dirt, and you can actually get a seal, right? You can cover this with like a nice glass panel so that nothing gets inside it, and it'll always stay clean, which is very, very nice. Love that idea. Who likes to have a clean miner? I do. Except right now I'm dealing with air cooled, right? Even in my shed with air filters and stuff, somehow pollen still gets in. It blows my mind, and I have to deal with that and clean it out. So it is part of that. Sure.
Yeah, so does that mean, the predominant source of the noise or decibels from the fans? Is that what creates the noise?
Absolutely. Uh,
Okay, okay. Hence almost no noise, right? Basically, without the need of that.
right. And it's
Understand.
and it's almost no noise. Right? I mean, there's a little bit of noise because you still have to have a heat exchanger, and that usually is in the form of like one big giant fan. But usually, the larger the fan, the lower the noise floor actually is. Now, if something about sound that I'll just mention around here, right? Low frequencies, right? Things like bass and all this kind of stuff, right? Require a lot more power in order to be audible. So the larger the fan you have, the more air you can push, which means also the lower the pitch of the air that's being pushed out, right? So we're actually able to still have a little bit of noise, but that noise is significantly reduced because we're also using a bigger fan. It's a lower frequency, which is harder to make louder. So higher frequencies like the ones that are stuck on miners themselves for air cooled are a lot more annoying because, they're roughly around, here, the size of my hand, and they're loud as hell, and they're smaller with these fans, so they make a higher pitched noise, and it's like a very annoying, like wee kind of sound. It's very, very bad. But yeah, that's a
I'm guessing they have to spin it an hour or they're small as well.
exactly. So bigger fans don't have to spin so fast because they move so much air from their size. So awesome, great question. Any other questions before I move on?
Real quick, I remember in our pre-conversation before you started, you mentioned that other people have like use it to heat their pools and stuff. So I mean, would a fan or pump be more of a cooling source since they're exchanging the heat into pool water and stuff?
So the pool water could definitely be something that is help of a heat transfer, right? Because as it moves through the pool is a little colder than it is. But at some point, I mean, I think it depends on the size of the pool and all that kind of stuff too, and how much your pipes are actually heating the pool, because you can actually overheat the pool. You could actually start getting inside the pool, and it's actually more of like a hot tub rather than just a warm pool. So you got to be careful. The hot tubs are great, but you don't want to stay in a hot tub for too long. You literally cook yourself. So, but yeah, no, there's that's a little bit more of a complicated question in terms of what the size of the pool it is and whatnot. But it certainly will add to the fact that you wouldn't have to maybe necessarily have as big, as powerful of a fan to cool the immersion setup. That's for sure. So some people do get very creative, and they find other ways of cooling down their stuff. And also, like we've said, I've seen people take the heat and actually convert that into their boiler, for their household water. Very creative. Great way of recycling the energy that you're already using. Okay, let's go into the difference between immersion versus air cooled for a second. So immersion mining also handles mining machine heat and noise more effectively than air cooled. We said this before, but unlike fluids, air is not a good conductor of heat, and while it is very possible to build a low noise or even noise-free ASIC container in an air-cooled setup, immersion setups are on average even much quieter than that. So immersion cooling does have some drawbacks, such as the need for specialized equipment, right, and a higher upfront cost compared to air-cooled mining rigs. Additionally, maintenance and cleaning of the immersion cooling system can be more complicated than traditional air-cooled systems, right? So if you don't have like a perfectly sealed, what do they call it? Hem something chambers. I forget that there's like no air gaps and stuff. I forget what they call those. But if you don't have one of those perfect things where nothing gets in it at all, okay, you're eventually going to have to clean it at some point, right? It may not be as quickly as an air cooled system, but it is something that you have to think about, right? And if gunk gets inside your immersion setup, that's going to start clogging pipes after a while and all this kind of stuff. So you want to make sure that you're still always maintaining a high level of operations here. Okay, when you choose to go immersion, it's best to over prepare than under. If you're under prepared, it's kind of one of those sayings, right? I'd rather have it and not need it than need it and not have it, right? This is one of those moments. And the quality of your system, the better it is, the longer your thing will last. So let's go into longevity in this case. Miners should note that building an immersion cooling system is more expensive than building a standard air cooling setup. So immersion cooling can also extend the lifespan of these machines. Economically, building an immersion setup makes sense for miners who want longevity. Xeno, right? Noise reduction and the ability to move heat further distances away from the source. It's very cool, right? You could have literally your entire immersion setup in your backyard, have the pipes run in, and do like this thing I was talking about, operate your boiler, and then come all the way back, right? It actually works perfectly fine to do it that way. So immersion cooling setups can range from a few $100s to thousands of dollars, but the investment should be chosen wisely as it is much more complex than air-cooled setups. At the most basic level, if you're interested in getting into immersion, this is something I would recommend doing. Something like a single Bitmain S9 in a small tank with a small radiator is the best, simplest place to start if you just want to learn how to do immersion, okay? Even if you have, honestly, you don't even have to get an S9. You can get one of these, gold shell box miners, right? If you want to try just doing something like that. You use something like a fish tank, right? And try to use that kind of setup in just learning what it takes to build immersion mining infrastructure. Now, the price and complexity increases significantly, of course, once you go beyond a single setup. So if you're planning on doing something that's more than just one ASIC, or more than one GPU for that matter, you're going to have a little bit more of a complicated setup, but, that's just kind of how it goes. You want bigger, you got to spend bigger, right? So this is something that I'm definitely curious in doing, but I have a different way of how I plan on doing it. There's a very good company called Octominer that does, GPU server racks, specifically for mining. Octominer. That's the name. But they actually unveiled a new product that is more of a home-based, all-in-one immersion mining container. Very, very cool. And that's something that I'm very interested in doing myself. So just something of a point of note. So let's talk about some immersion basics. Understanding some of the key terminology will be critical before we pursue immersion cooling setups. So here are some of the more common terms that we see simplified. Dielectric coolant, which is an engineered fluid. That's a key point. It's an engineered fluid. It's like made in science labs and stuff like that, okay? We don't just find it anywhere, all right? It has zero electrical conductivity, but reasonable thermal conductivity. And I'll mention that in a minute because We're dealing with oil, which means that oil is flammable, okay? So just be careful. There are many products to choose from with varying properties such as corrosive properties to materials such as rubber. This is a significant expense of the immersion setup. So if you get, engineered fluid, dielectric coolant, okay, it's less likely to corrode and all this kind of stuff. And we'll talk about that because of the impurities of stuff like mineral oil, for example. The ASIC tank on itself is a container or enclosure that holds the ASIC and the coolant inside. This can be made of steel, aluminum, glass, like fish tanks I mentioned, or wood coated in fiberglass. So that's very cool. Brazed plate heat exchangers. Okay, this is used to transfer heat from a fluid on one side of a barrier to a fluid on the other side without bringing the fluids into direct contact. Okay, very, very cool. It's basically kind of similar to, does anybody here operate a like a water cooled PC at all? There you go. So it's very similar to that kind of technology, if you think about it that way. So we're just kind of making this on a much bigger scale instead. We also have a
It's like a heat exchanger.
Yes.
But like a radiator in your house exchanges the heat and air, but that's using like the liquid, which is better conductive and more efficient heat exchanger.
Exactly. Perfect explanation. And that's basically what you're doing with an immersion cooling setup here. We're basically doing one big giant freaking water cooled ASIC. Yes. So actually, there's also a water to air heat exchanger, which is removing heat from the liquid and venting that into air, right? So in other, there are two kind of ways that we can do this. We got like double loops and single loop type of immersion setups, but both can use water to air heat exchangers as well as brazed plate heat exchangers for a double loop setup. Just something to think about, but these are some how would you say, supplies and materials that we would use within an immersion setup. The pump, okay, big part of this, circulates the dielectric coolant and ensures that it flows continuously throughout the system. One thing about a pump that you have to be very, very conscious about, though, is that you don't want to just use a normal water pump, okay? You have to get like actually a more specialized pump for something like this. Otherwise, if you get, cheap components, because water is not the same as oil, okay? Water will not corrode as quickly as maybe oil will, okay? Oil is much stronger in that sense, and it has other impurities inside it. So with water, you can get by with a cheaper pump and all this kind of stuff. That's why, fish tanks, they're like, they're not a lot of money to get, a water pump. But if you're going to get something for oil, it's going to have better sealant, and it's going to also be made of material that's not as corrosive, so it's more expensive. Okay, don't get a cheap water pump for your immersion setup. You're going to regret it later. Okay, single loops. The dielectric coolant is pumped directly through a radiator, and the radiator cools the fluid and then feeds it back into the ASIC reservoir. Very simple, like all-in-one type of water-cooled PCs and stuff like that. There's a coolant that basically goes to the radiator. Radiator fans push out the heat, then it comes down and it becomes cool and goes back to the CPU. The double loop, however, is first pumped into a heat exchanger, like the bronze plate that we were talking about, and the heat from the exchanger is then transferred to a water line. So it heats up water, a water pump. In this case, this is what some people use for their pools and stuff like that, right? So they try to, use the pool itself as a water line, essentially. So the heated water is then pumped from its own loop into a cooling tower or dry cooler and cooled down. This second loop usually contains a water glycol mix, as glycol is a better conductor of heat than simple water, which is what you see with a lot of water-cooled PCs, right? It's just water and glycol together. It's a better conductor. Okay. Any questions before I move on?
You mean glycol like antifreeze?
Yes.
Okay, quick question. Whenever you pump something or pressurize something, is it a byproduct of that to add heat,
Yeah,
process of pressurization doesn't add any heat to it.
sure, sure, absolutely.
So what type of pump would you use that would pressurize the liquid without adding heat?
Good question. And I don't know if I can answer that right now, but I would love to do some more research and get back to you on that. So let's, any other questions before we move on? Now, mind you, this is still something that I'm interested in myself. I don't have all the details, but I would absolutely love to answer some of these questions. And you guys bring up some great questions as we go through this. So, you know, as much as I'm trying to teach you, sometimes you guys can teach me something too. So that's a great question that I'd love to explore a little bit more. Okay, so let's go into fluid types. Fluids absorb the heat produced by the ASICs and disperse it through two possible methods depending on the type of dielectric fluid that will be used. We have single phase, where the system pumps the heated up liquid to a heat exchanger, a device that transfers heat between those two fluids. And the exchanger then transfers the heat from the fluid to a cold water circuit and returns the coolant liquid to the bath, restarting the process. The bath is where the ASIC is submerged inside, this dielectric coolant. Then you also have two phase. Other coolant fluids evaporate when they reach a specific temperature. And in this method, when the coolant turns into a gaseous state, the gas rises, meets a condenser used to turn a gaseous substance into a liquid form through cooling, and drips back into the pool. Then the condenser releases the heat through the air. Now, a single loop is where the entire system is comprised of dielectric oil. The heat from the oil is exchanged to air. This is the most easy to set up, but it's the least scalable. Also, in the event of a leak in the system, you're going to risk losing some or all of your expensive dielectric coolant. Again, it's a big part of the cost, right? So we want to make sure that if you use something like a single loop, you've tested it properly before you go ahead and start putting dielectric coolant in. It might not even be a bad idea to start off with just water, just to see that the water is going through and there's no leaks, etc. And then, making sure it's dried out, flushed out, and then putting in the dielectric coolant itself. We also have a double loop, which is where an oil loop goes through a brazed plate heat exchanger or similar and transfers its heat to another liquid, such as water or glycol. And the benefit of a double loop system is that less total oil can be used, which becomes a much bigger factor when going beyond a single miner or two, but it could add expense depending on the setup. So it's another sort of efficiency factor, right? So again, if you're talking about building on a giant scale, you're going to probably want to do the double loop and all that kind of stuff because you can scale at a much more reasonable cost. Over time, right? Up front, it's more expensive, but double loop will be more efficient with more miners in case. So in both cases, the immersion liquids dissipate the heat from the bath, keeping the temperature of ASIC miners low in an effective and energy efficient manner. Any questions about this?
One quick question. Double loop sounds almost like a car AC systems where it has a condenser. And
Yes.
if I can capture it and use it, am I hearing that correct?
Yeah, kind of similar in a sense. Yeah, cars are using this kind of system where they have sort of a double loop going. So you're not wrong. A little bit different, but same concept.
Gotcha.
All right, preparing for immersion. So in order to prep machines, miners will need something called fan spoofers, or you can get specialized firmware to do this. There are a couple of different things like Brains OS, or you can get Luxor or stuff like that, that they have ways of customizing for the immersion setup for an ASIC without you having to change the fan spoofers and stuff like that. This is necessary because ASIC fans are not meant to be submerged. Okay, submerging them in oil will change the fan speed and impact how the ASIC functions. So because ASIC fans are meant to churn through air, right? They're literally chopping up air. The moment you put a fluid through them, now there's a form of resistance. So now this has to work overtime, in order to make it, through. And if you start doing that and it starts, working overtime, it's sending signals to the ASIC that it's like, hey, I can't heat this as well, so you're gonna have to slow down your hash rate, etc. Okay, you're gonna have to chill out. And the ASIC's gonna be very confused. So you have to remove the fans. If you don't remove the fans, that just creates more problems. But fan spoofers have been around for a little while now, for a couple of years. And people basically, they plug them in place of the fan connectors. So it tells the ASIC that it basically still has a fan, but it's not. You're tricking the ASIC essentially. But there must be a means to have a flow of oil over the ASIC, making sure to see if the ASIC needs a spoofer with 4 pins or 6 pins. It's different for ASICs, around. So you're not going to find the same type of fan spoofer for a Bitcoin miner versus a Cardano miner or etc. Better solution to fan spoofers though is basically installing immersion specific firmware. What's Miner also offers this, its own immersion ready firmware. But like anything, it does void the warranty even if you do immersion. Okay, so but even more specifically for What's Miner, it voids the warranty for the What's Miner if you install it. So in general, immersion cooling setups, they will void warranties. So if you are planning on doing immersion setups, I highly recommend that you have some form of an air-cooled setup for testing at least, just to see if the miner is working in proper order, because if it's a faulty miner and you already submerged it in immersion, then you're kind of screwing yourself in the back end there. So just, do your due diligence and make sure you test your equipment before you put it in there. However, all immersion activities effectively void warranty anyway, so this poses a risk to the process, and miners should be verified that they are in working order before submerging, like I said. Sure. True. Yes, that's a very good point. Testing your miner and seeing what your miner can do, and also seeing if it won the silicon lottery, so to speak. All great points, and I'm glad you said that. Any other questions before moving forward? I love that we got the whole team here, man. This is great. All right, let's talk about the difference between mineral oil versus synthetic oil. So mineral oil is, one, it's cheaper, it's more accessible. And so if you're, going to begin immersion mining, you might think, oh, well, getting the engineered fluid is going to be much more expensive right now, but if I were to get mineral oil, I can get started right away. Well, let's talk about this, because mineral oil can be used. It absolutely can be used. But longevity, if that's what you're trying to go after, we might think a little bit differently about that. So synthetic dielectric fluid is the alternative. Both can conduct heat and not electricity, and dielectric fluids are replacing standard mineral oils in both stationary and mobile cooling applications because of their exceptional stability, cleanliness, and heat transfer characteristics. I say that if you're doing an experimental setup, like, go for mineral oil. Like, you're trying to figure this out, and see if this will work. Don't get all the crazy expensive stuff if this is just an experiment, all right? But if you want to, let's say you build your own little immersion setup at home because you're testing that out, but then you're like, okay, I think I know how this goes. I want to scale this up, and I want to build something better and newer and more professional. Then go for the engineered fluid, right? But base oils used in blending dielectric fluids were created by a chemical reaction, and as a result, they are far cleaner than mineral oils. This helps with issues such as oxidation resistance and material compatibility, right? So corrosives and all that kind of stuff. It helps with using synthetics. They also have a very low pour points because they don't contain waxes, which makes them ideal in applications at very low temperatures, right? So if you're living in a very cold place, the mineral oil might have actually some solidification if it's too cold. So this makes them ideal for that. So mineral oils have been used in electrical cooling oils for many years, though, in distribution and power transformers. And chemically, mineral oils are a mixture of many different types of oils and contain impurities such as metals, soaps, and salts that pass through the refining process. There are 8 important characteristics to consider when we evaluate a heat transfer fluid in electrical cooling applications. These will be the heat transfer effectiveness, electrical safety, flammability and fire safety, oxidation stability, material compatibility, worker health safety, biodegradation and environmental fate, and the cost, right? So some things that maybe you wouldn't necessarily have to worry about in an air-cooled situation, right? But it's something that we all have to consider if we're going into immersion. So let's take a look. Flammability, being that immersion fluids are essentially oil, there is a burning point. And here are some of those points that I've been able to look up on the internet here. But dielectric coolant, roughly somewhere between 160 degrees Celsius to 200 degrees Celsius, or if you're in the Americas like me, 320 degrees Fahrenheit to 392 degrees Fahrenheit, somewhere around there, which is the standard for most immersion mining appliances. Comparing that to something like white oil, that's a highly refined premium quality mineral oil that we use in food processing plants, consumer products, and other applications. That's somewhere around 130 degrees Celsius, 1 to 150 degrees Celsius. Polyalpha olefin, PAO, okay? 140 degrees Celsius, a synthetic hydrocarbon oil. This is something that is developed in a lab as well. It's an alternative to dielectric coolant, but it is at a lower thermal point. You also have petroleum-based oil, somewhere around 140 degrees to 180 degrees. Comes from crude oil, and quality depends on the refining process. This one you might want to be a little bit more wary about. This is kind of like the standard mineral oil that we would use. Okay, so another comparison summary here. Breakdown strength. This is the quality of the fluid. Breakdown strength is basically a parameter where the voltage can cause a dielectric failure, leading to spark and create fire. Okay, so that's another factor that we're thinking about, where if the fluid, right, if we have too much voltage in it, right, which we can have with miners, right, how likely is the fluid to respond to like a surge or something like that and spark a flame? Okay, so this is why, doing something like, if we go back here, right, you got this white oil, right, or like a petroleum-based oil, or even polyalpha olefin, PAO, okay? If we get these kinds of oils, they're more likely to respond to that sort of heat from a voltage spike, which is one of the reasons why we decide, for safety, dielectric coolant is much better across the span of this stuff. So characteristics of dielectric fluids and mineral oils on 8 key parameters for electronic heat transfer. Describe how lower viscosity and viscousness is essentially like resistance to flow. Okay, so if we talk about, let's say, if you were to have like a little ramp, right, and you were to put water from the top of the ramp, it would flow quite fast to the bottom, right? That's low viscosity. But if I were to, pour ketchup at the top of the ramp and let that try to flow, that would flow a lot slower, right? So that's what we call, more viscous. It's more thick. It's all this kind of stuff, right? So viscosity, lower viscosity, And better heat capacity of dielectrics offer a significant advantage here, which is why, investing in something like a dielectric coolant rather than using mineral oil is a big part of that. Dielectric coolant is lower viscosity comparatively to that mineral oil. There's that impurity factor that I was talking about. There's also a difference in electrical and flammability characteristics of dielectrics versus mineral oils, and one of those key differences is that dielectrics have been processed to move the impurities containing additives and have been tested and certified meeting international safety standards, etc. Any questions? Great. Okay. Here's a quick shopping list. Basic immersion cooling builds will include the following. Immersion liquid. This would be your coolant. You need a container for your ASIC. You need a heat exchanger, right? You're depending on how you're going to go about, with a single or double loop. A lot of people, when they do stuff like this, I believe they use something like copper for their piping. That's a very popular one. You also have the dielectric fluid pump. Okay, you need an oil pump, a radiator in order to dissipate the heat, and a fan to be paired with that radiator. And you also need the fan spoofer or the immersion firmware. That's basically at the basic level what you would need here. Immersion cooling setups, in summary of what we've talked about today. Immersion cooling setups are ideal for miners who wish to extend the lifetime of their machinery and control noise and heat as efficiently as possible, or push the miner beyond its original power rating, which we call overclocking. Single loop works well for small setups. Miners operating larger scale setups should consider using a double loop setup. Miners who do not have an engineering background can use something like an S9, mineral oil, a fish tank, low cost pump and radiator, and install something like Brains OS Plus and experiment before investing in a more expensive build or submerging their more expensive machines. Okay. In the end, there are companies like Octominer, Engineered Fluids, DSI, etc., who have solutions for immersion. It's always a good idea to also consult an immersion mining representative to find out what works best for your situation. Okay, right? I am exposing you to immersion mining today. I am by no means a practicing immersion mining operator. Okay, so this is as much of a learning experience for me as it could be for you. And one day in the future, I hope to incorporate immersion mining setup in my own home, but that will take some time. In the meantime, we can benefit from Xeno mining, going and building an immersion setup for all of us with our NFTs, which is very exciting. But that concludes for our class today. Are there any final questions, or let's just open up the chat? Is something you enjoyed?
I didn't very much. Anybody else did, but yeah, I found it very intriguing, thought-provoking. My juices in my brain are working on other ways, like I said, to other things that could stem off from the immersion mining process.
Awesome. That's great. Yeah, get the wheels turning. And I love to see all of our, so much of our team is here today. It's a very important, I think, factor for us to understand as much about, what we're doing here at Xeno. So I'm glad to see so many of us here today. I would love to ask if anybody has any recommendations as to what they would like to learn for our next class, and I can, potentially start looking into that and start prepping for it. And if you don't have anything to tell me today, it's okay. We can certainly post it in the general chat, or we can certainly you can tell me in the mod chat. Don't matter. So who was that? There's like 3 people at once. Let's see here. Also, let me stop the recording. Last time I think I asked somebody who wanted to really talk about like environmental impact and stuff like that. It's certainly something I can look into. Some of this